So today in class, we talked a little bit about multiplying binomials and other stuff like that. There were problems like this, for instance, where we had to multiply the x times both things. It's a distribution problem, so x times 3x is 3x squared, and x times -7 is -7x, and they're done. The same thing would be true if we had 2 times 3x minus 7. We would multiply the 2 by both things, and we would get 6x minus 14, for instance. But if we had x plus 2 times 3x minus 7, really what we're doing is the same exact two problems, where this is the x plus 2 part getting multiplied by 3x minus 7 both times. So you end up with all four of these products over here, 1, 2, 3, 4. But you'll notice that these two are like terms. So when you have x plus 2 times 3x minus 7, one way of multiplying them is by doing repeated distribution. Multiply the x times both and multiply the 2 times both. And you end up with this 3x squared. Now 6x minus 7x is minus 1x, or minus x, minus 14. The middle terms combine together, and that's what we get. So that's the kind of thing we've been doing. This is one way of doing those problems, and we have lots of other ways that we can do them too. So for instance, I'm going to show another binomial multiplication. Let's try 3x minus 4 times 2x plus 8, or 2x plus 9, let's see. And I showed another method called the box method, where you have a 2 by 2, two things multiplied by two things, so you have a 2 by 2 box. And on the outside of the box, you put one of the terms over here and one of the terms over here, and it doesn't matter which one you put where. So we could have put the 3x minus 4 along the top. 2x times 3x makes 6x squared in this box, because 2 times 3 is 6, and x times x. The next one over here is 9 times 3. That would be this one times this one. 9 times 3x is 27x. Then we multiply -4 times 2x, which is -8x. And -4 times 9, which is -36. Just like on the last problem, these two things over here along these diagonals are going to be like terms because they both have just an x in them. So our final answer is going to be 6x squared, that's the first term, 27 minus 8, which is 19x, minus 36. So that's our final answer for this problem, 3x minus 4 times 2x plus 9. So that's a second method, using a box like this to be able to get our answer. Some people just do these things in their head, and that's okay too. Whatever works. So another example would be, let's try a different kind here, 7x minus 1 times 2x minus 3. And I'll show a vertical method, which would be the same way we do multiplication problems that you first learned when you first learned how to do multiplication. So -3 times -1 is positive 3. Then we do -3 times 7x, which is -21x. Then you go to the 2x and you multiply it by both things. 2x times -1 makes -2x. 2x times 7x makes 14x squared. Notice when I wrote them down here, I got it so my like terms were lined up. So our final answer is 14x squared minus 23x, combining like terms, plus 3. So that's a third type that you can use, or you can use whatever method works for you. So I'm going to do one more example. Let's see. How about if I just make up one, x minus 5 times 2x plus 5. And I'll use FOIL this time. FOIL is the same thing as all the other ones, except the first thing you do is you do your first term would be 2x squared, right? Your outer terms would be x times 5x, which is 5x, or x times 5. Then you do your inner terms, which is -5 times 2x, which is -10x. And your last terms, which are -5 times -5, -5 times +5. Again, we have like terms in the middle, so our final answer is 2x squared minus 5x minus 25. So this is about multiplying binomials together or just distributing to know how to do that. We're coming to the point where we're going to be talking about how you start with this problem and you end with it in factored form. So for instance, there's a whole set of videos on these, but just so you know, one of the problems on the problem set that I'm giving you would be looking like this. Say something like x plus 8 times something equals x squared plus 10x plus 16. You say, well, what's missing? And you'd say to yourself, well, I know that the way these work, think about it. If I do it in a box, for instance, I know that there's an x squared and a 16. It's just these other two boxes add up to 10x. So for instance, if one of the factors is known to be x and 8, then we're going to automatically know that the top part is x, because x times x is x squared. And this other one's probably going to be 8 times 2 is 16, right? So where does the 10x come from? Well, this term up here is 2x. This term down here is 8x. And of course, they add up to 10x. So our missing term is x plus